Okay, so this is class for Monday or Monday, November the, what is today? November the 8th for my grade 11 applied students. And we're gonna start by just finishing up the last example. And there we go, in the 5.1 lesson. So we made it to, we got through all these things here, and then we got to this last one and we ran out of time. Okay, now some guys discovered that the Calculator Soup online calculator that we were using for statistics on Friday, if you take a picture on your phone, it'll actually, if you have the right kind of phone and the right kind of picture taker, it'll actually, you can just put the data in without having to type it in, and that's pretty sweet. I wasn't able to do that with my my cut and paste tool for Microsoft. So here's what I did. I just opened up a Word file. Actually, I had a Word file for these notes. And I just typed them in Word just to make my life easier. So we are going to compare mean, median, mode, and range for these two brands of cars. So I'm going to open up Calculator Soup, which I've already kind of opened up. Feel free to just Google Calculator Soup if you want. So Calculator Soup has, and when you go to Calculator Soup, you want the one that says Basic Statistics Calculator. And then you're going to enter all these data points from the example. And you'll have to do this twice. So you know what, feel free to open it twice. And then we can compare them. Okay, so I will open, so I'll go back to my Word file. And I'll just copy and paste these numbers. So I'm going to use my mouse instead of the laptop mouse. There we go. So copy, and then go back to the Calculator Soup page, and paste. So there we go. And then hit calculate, and it'll give you all of the data that you want. Okay, and then I'm going to do this again for the other set of data. Also remember that it, and this surprised us on Friday, it also organizes it from smallest to biggest for us. So that if we needed to find the mode ourselves, we could, or if we just wanted to sort of see the data in order, we could. Okay, so now let me do the other one. So that was X. This is Y, battery Y. So copy and paste. Calculator Soup and paste. And you have to put either commas between the numbers or spaces. Either way, it knows that you're starting a new number. Calculate, and there we have it. Okay, so we will pause the video while people enter stuff in. Actually, I can give you a third option too. If you don't want to use Calculator Soup, you can actually also use Desmos. Desmos, you do it like this. You'd enter A equals, you have to put a capital A equals, and then open a bracket for a data set, which is this square data, square bracket, and then go back, and again, you can go to the data set. And unfortunately, I think Desmos it doesn't understand spaces, it only understands commas. At least I think. Let me see if I'm right about that. Copy, and then go to Desmos, and paste. Oh, it's not letting me do it. Interesting. Okay, maybe I'll do it Control V, Control Z. So, Control C, and put your cursor in there, and Control V, and yeah, unfortunately you'll have to go back and tidy that up. You'll have to kind of, it interpret all of the spaces as decimals. Or actually, no, you know what, it didn't understand the spaces at all. So you're gonna have to go back and put commas here, 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 here. This is a bit of a drag. So while people are entering their data in whichever device they choose, or whether it's the calculator or their online. So you have three options. You can use the TI calculator, you can use Calculator Soup, you can use Desmos. And of course, if those of you who are using the calculator, let me get the calculator up and running. I've already done the calculator because I did this on Friday. And the calculator is the one technology we're using that saves things. Oh, I guess actually Desmos saves things too. If you have a Desmos account, which is free. I highly recommend you get one. So let's see. Go to Stat, and then Edit. And I have the two X and Y datas in L3, List 3, and List 4. So I will pause the video while people enter their data wherever they're entering it, be it Calculator Soup or Desmos or their calculator, and then we'll come back once everybody's got their data entered, okay? So we'll pause the video while people enter data. Okay, hopefully that was enough time for people to enter some data. Even if you didn't quite finish all of this, you could always do it later yourself. But here it is. Let's go to Calculator Soup first. So in Calculator Soup, according to, this is the first data set, this is X, we have a mean of 5.743 and a median of 5.75 and a mode of 5.7 and a range of 5.1. So I'm going to go to my booklet here and say, okay, compare the mean, median, mode, and range of each brand. So I'll start writing up here. They give us some room. So for brand X, and flip that over. So for brand X batteries, the mean lifespan of the battery, should use an equals, was 5.743. The median lifespan of the battery was 5.75. The mode is 5.7, and the range is 5.1. For battery Y, let's go back to Calculator Soup, and let's see what the Y data is. There it is. There's the Y data. So it's very close, actually. There's actually not much difference between these two brands, and that's kind of by design. So the mean is 5.76. The median is 5.8. The mode is 5.9. And the range, in this case, is 2.5. And that's the number that I think makes this battery my winner. I know what you're thinking. You're thinking, well, 5.76 is not a whole lot better than 5.74. And 5.8 is the same as this number rounded to one decimal place. Why do you say that this one's better? Well, because it has a smaller range. So the smaller range on battery Y indicates that you are more likely to not get, okay, we're going to use a very technical term here, a dud. A dud battery from company Y, right? The fact that this range is bigger than that range means that the data is more spread out. This data has more of it closer to the mean. We're going to learn in the next part of the chapter, actually the part that we're going to do tomorrow, that there is a technical way to measure how close all of a data set is to its own mean. It's called the standard deviation. And we're going to use this data to just show that sometimes mean, median, and mode don't really tell the story. They're just too close to call between these two battery brands, but the measures of dispersion, the range, and what we're going to learn later is the standard deviation, mean that I would rather buy battery B. I'm more likely than not, battery Y. I'm more likely than not to get a good battery, whereas from X, the fact that this range is more spread out means that there is at least some batteries in my block of 30 batteries that were tested that were really low and a long way from the mean. Okay, question from the audience. because the range is smaller, right? So remember what range is? Range is the largest value minus the smallest. The smaller the range is, the closer the data is to this mean. Whereas over here, the fact that the range is bigger means that some, at least one of the data points was quite a bit below this mean. And then I don't really want to be the guy stuck with that battery. I'm not very likely to get that lower than usual by a lot battery if I stick to brand Y. So mean, median, and mode didn't really tell the story on this one. The range was the better one. And again, if this was chapter 5.3, I'd have another statistic called standard deviation. In fact, sneak peek, I think it's probably on there, isn't it? There it is. The standard deviation is 0.65 versus 1.24. The standard deviation is almost twice as high on this one as it is on that one. And we're going to learn coming up soon that that means that in this case, that's the one I want because its data is all closer to its mean. So I'm much more guaranteed to get a battery that will last as long, at least as long as the mean, if I choose brand Y. All right. Another way we could, of course, do this data is to look at it on a graph. Now, for the homework for this one, I actually avoided the questions involving graphing because we're only going to graph by hand once. In fact, we'll do that right away here. So can everybody turn to the next page? Oh, we got one more question about this. Lay it on me. What do you got?
So if the range is lower, that means there's less deviation between all the data points?
That is exactly right. The question was, so if the range is lower, does that mean there's less deviation between the data points? And the answer to that is yes. Okay, next. Hang on. That was 5.1. I'm going to have to, do I not have all of this? Oh no, I only have 5.1 on here. Okay, so I'm going to have to add a new booklet. Let me just pause the video while I do that. Okay, sorry about that. Let's get rolling. First, we need to do a couple of definitions here. What is the definition of a frequency distribution? A frequency distribution is a way to organize data sets, I should say, into intervals. Another word for intervals here is classes. Where the values in the set are counted as you would in a tally chart. And this is where people's ears perk up. Tally charts, that was my favorite math thing to do in elementary school. I was the best at making tally charts. Sometimes your teacher would let you use stickers to make the tally charts as they climbed up. What they were, of course, doing was setting you up for understanding bar graphs, right? Bar graphs are essentially tally charts. So let's take a look at some data here that's been grouped in a frequency table. What does this data mean? It means that I have a set of data where the value 25 has happened 12 times. So the data value 25 occurs 12 times. Oops, come here you, 12, And then by the same token, so the number 26 happens 14 times, the number 27 happens 12 times, etc., etc. Okay, so what do we do with this data? Well, once again, if you're using an online device, we're going to use a different one today. We're going to use one called the Frequency Table Calculator at hackmath.net. So feel free to type in your browser hackmath.net If you happen to have this document downloaded onto your device, because I told you you could download it from the blog yesterday, then this, of course, is a hot link. So you could just right-click on your phone and open it from there. And when you open it, it's going to look like this. So let me get to it. This is going to open it in. Okay, hang on. Open. There we go. This is going to open it in Edge. We're going to just pretend we like working with Edge on my computer here. And so there we go. You get this frequency table calculator. And this is a super easy platform to work on. You enter the data as a list with commas, and then you tell it what the frequency of each point is. So the data that we're looking at is the data points 25, 26, 27, 28, 29, 30. So 25, 26, 27, 28, 29, 30. And then we have to tell this thing, you hit enter, and on the next line, you have to tell it that these are frequencies. So you type in F, and then a colon, and then you type in what the frequencies are. So the number 25 happens 12 times. The number 26 happens 14 times. The number 27 happens 12 times. The number 28 happens 8 times. The number 29 happens 4 times. And the number 30 happens 0 times, which you'd think shouldn't really even be part of your data, but they put it there, so we'll enter it in. And now it's going to do all of the calculating that the last calculator did for us. Mean, median, mode, range, all of that. Okay, we have a question. Anybody else having problems? Somebody's saying that it's not opening the way it's supposed to.
Internet is sucky right now.
What's that?
Internet is a bit sucky.
Oh, okay, then the issue could be the Wi-Fi.
Wait, how are we supposed to put it in?
So you type it in, okay, so let me just go back to the question here. Let's see. So here's the notes. Okay, so there's the notes. So you enter these values. So that basically you have to imagine that this data, this is a very large table of data. And in that table of data, the number 25 happens 12 times. The number 26 happens 14 times. The number 27 happens 12 times. The number 28 happens 8 times. Sitting there and calculating with your calculator mean and put even median, you'd have to line these up and write down 25 12 times, then write down 14 26s. This would take a long time. So that's why we're using the technology to do it. So we're going to use, again, hackmath.net. And if you go to their main page, it'll probably ask you for what calculator you want. But this address here gets you right to it. And here I am at that address. So I'm entering the left column, which is all of my data points. And then the right column, I'm telling the calculator how many times each data point happened. So the calculator knows that that's what I entered. If I enter F, full colon, and then each of these numbers corresponds to the data point. So 25 happens 12 times, 26 happens 14 times, 27 happens 12 times, 28 happens 8 times, 29 happens 4 times, 30 happens 0 times. And then I hit calculate. And boom, it'll tell me my data. You have to scroll back. It's going to give you the same chart that you just had. So there, right there, this left part here basically is the chart that we started with. Scroll past the ads, sorry about the ads, and there you go. We have a mean. Now they use a different symbol for mean than we do. We use X with a line over top of it. Some statistics classes and stats teachers and stuff will use a Greek letter. That's the Greek letter mu. It's like a U that has a tail on the front of it. So if you ever see mu out in the field, that's the same thing as X with a line over it. It's the mean. And then keep looking down and you'll find the median. So let me go back to the notes. I already plugged this into this calculator in the notes. So there's all of the data we got right there. And what we're looking for, of course, is we're looking for the mean, the median, and what else did they ask us for? They asked us for determine the mean, median, mode, and range. So let's see, does it have all that stuff here? It has the range is at the bottom, the median's here right here at 26, the mean, again, the average slash mean is here, and there we go. And the mode, oh, the mode is 26. Ooh, and they have this fancy word here, unimodal. What is that telling you? It means there's one mode. Get it? Uni means one. Remember, it's possible in data to have more than one mode. So there we go. So for our example, there's the answers. Feel free to write those down. Actually, you have it in your notes. You don't have to write it down. So there we go. So there's this. Now, what if I wanted to use my graphing calculator? Okay, for the graphing calculator, you would enter this. Again, I'm going to go to, so guys with the graphing calculator, I'm going to go to my lists here. And I'll use list 5 and list 6. So, okay, so list 5 and list 6. So I'll pause the video while I enter the data, and then we'll use the calculator to solve it. So start entering the left and right columns as you'd see them on the chart in your notes, and then I'll enter them, and then we'll get back together here in a sec. Okay, TI calculator users, here's the data, and again, this left list is all the data points, and the right list is how often they happen. So now I would like to do mean, median, mode, and range. So I go second function, no I don't, sorry, first function, go to stat, calc, and it's this time it's two variable statistics. So go to two variable statistics. Oh, actually, no, sorry, no, it's not. It's still one variable. My bad. It's still one variable statistics. But this time, you have to tell the calculator that you need list 1 and list 2. So it's one variable stats, hit enter, and then you type in L1, which is shift 1, comma, shift L2. So there you go. Make yours look like mine, and then when you hit enter, boom, there's all of the same stuff that we got from the HackMath frequency calculator. Only not quite as much. I put a little note here in your notes just to make sure to kind of try to chill you out a little. Don't worry about the fact that these calculators online give you way more information than you want. Remember that these were designed for students in university or maybe even professional statisticians. So there's going to be lots of things here that are a little beyond the scope of grade 11 statistics. Okay? The graphing calculator was actually designed more for high school students, so there isn't a whole lot of extra baggage on the graphing calculator. Whoops. Go back. Where are you, calculator? There you are. So on the calculator, as you can see, we have the same mean, median, mode that we had in the notes. And of course, how did you find the mode on the calculator again? Well, remember, to get the calculator to give up a mode, you actually have to kind of look at the chart. But remember what the chart is, right? The chart is just single pieces of data that happen a number of times. So as you can see, oh, you know what? I just typed one of them wrong too. Let me fix that. Type 14 for that one. Enter. And then go back to my stats, calc, one variable statistics, and shift L1, comma, shift L2, then hit enter. There we go. There's the right data. And like I was saying, when you want to find mode, you just look at the list. And mode's really easy to find in this kind of data because mode happens the most. Well, there it is. The number 26 happens 14 times. That's why its frequency is 14. So you can find the mode very easily. Okay, so that's a frequency chart. So there it is. There's the instructions in your notes for the TI students. Next, let me go back to where I can write. Next, we go to what a histogram is. Now, a histogram is very much like a bar chart, like a bar graph, but it is actually the graph of the data from a frequency distribution chart. The x-axis is the classes, or again, the intervals. And the y-axis is the count of how many values are in each interval. I'll give you a sec to catch up to my writing. That's an R. Give you a chance to try to interpret my crappy writing. Intervals, there we go. There. Okay. And in the notes they actually give you, oh, when I copied that over, the little diagram disappeared, but if you look in the notes, there's a little diagram of the Red River flow rates in Winnipeg, based on how many cubic meters of water flow over how many years. So there we go. So that's a pretty neat looking bar graph. Always important here in Winnipeg to make sure we have an eye on how high the Red River is. We've had a couple of dry years in a row, so it hasn't been any issue lately. But this is a very flat part of the world, people who are new here, and when the river gets high, we flood. We actually have built a giant ditch around the entire city called the Red River Floodway to make sure that the city doesn't end up underwater when we have a spring with a really high river. Okay, so that's the example that they show you here. Let me just show people who might be watching the video. Let me go back to there it is. There's the little chart that we were talking about right there. And you can see, in other words, this bar here represents the number of data points that were between 150 and 600, which looks like it was 11. This second bar here, I hope you can see my cursor from where you're sitting, that's how many times the data landed from 600 to 1050. And as you can see, it was 9 times. So we're going to make one of these ourselves. We're going to do the first one just with paper and pencil. We're just going to use paper and pencil and just try to draw on it. So these are the grades from Professor Potter's stats class. You know what? I'm going to recopy this so that we can draw on it better. I'm going to copy it with my snip tool. I tried Control Ving it and that didn't work so good. New. So we're going to make a tally chart here. Okay, so copy that. And let's go to the page where we can draw, and I'll just move over and put it right here. Oops, or maybe not. Come on. There we go. There. And of course, it doesn't want to put it where I want it to. There we go. Move over you. Okay, and there we go. OneNote is being particularly finicky today. There we go. Okay, so let's make a tally chart. Okay, we have some questions. Question?
When you're putting the data points into the calculator, does it need to be lowest to highest?
No, it can sort that for you. Remember we showed you, the question was, do we have to put them in from lowest to highest? Usually in a frequency chart we do, because you usually make your tally chart that way, as you're going to see in a second. But if you don't keep track of them from lowest to highest, it'll sort that for you. Remember we did that on Friday, we hit sort? Yeah, question? Yeah. Okay, so let's make a tally chart like the one we just looked at. All right, how do we do this? Well, let's say that we want to take the grades from, okay, nobody in Miss Potter's class here had less than 10%. So we don't need to keep track of the single digits. But we would like to keep track of all the grades that were in the 10s. So that'd be a grade of 10 or 11 or 12 or 13 or 14 or 15 or 16 or 17 or 18 or 19. So I'm going to count the interval from 9.5 to 19.5. Now you might be thinking, why go with 0.5s? None of the grades are 0.5s. Well, what I want to do is I want to make all of these intervals the same distance wide. And in this case, they're all going to be 10. But I want to make sure that the number 10 gets grouped in with the numbers 11 and 12 and 13 and 14.
An interruption.
Hello.
Is Hamza in class?
Okay, so the first interval is going to be from 9.5 to 19.5. The next interval is going to be from 19.5 to 29.5. And then we're just going to continue filling in the chart exactly like that. So 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, 59.5 to 69.5, 69.5 to 79.5, and 79.5 to 89.5, and 89.5, whoops, 0.5 to 99.5. And then I guess if there was anybody who got 100 in this class, they'd have their own bar on the bar graph. Or I could, if I wanted to, actually include the number 100 in with the 90s. But I'm going to decide not to. So people who got 100 are going to get their own bar. But in this case, they don't get one because nobody in the class. I'm looking at the data, nobody has 100%. As it should be. You got to be really exceptional to get 100% in the class. In my case, that means you got 0 errors in the entire semester. I don't round up from 99.5 to 100. I won't do it. If you got 99.5, you made a mistake somewhere. You're not perfect. If you want 100 from me, you have to be perfect. I know that sounds cruel, but that's me. All right. Again, there's probably people wondering, what's with the 0.5s? None of these data points are 0.5s. Notice that if we went 10 to 20 and then 20 to 30, well, which column do you put the number 20 in if it pops up? See, that would be kind of confusing, wouldn't it? I want the 20 to be in with the 20s. 21, 22, 23, 20. I want all those in one class or interval. So that's why the 0.5s. Does that make sense now? Like what again, if this was from 40 to 50 and then the next one was from 50 to 60, where do you put the score of 50? Which column does it go into? That'd be tough to figure out. So rather than guessing, this takes care of that problem. Question? Well, because 9 to 19, and then what happens, and then 20 to 29, okay, well, yeah, you could, I guess. But 9 to 19 would mean that the 9s would fall in with the 10s. See the problem? And I don't want 9 in with the 10s. I want 9 to be in the single digits. Like again, if this was 19 to 30, that wouldn't work. And if this was 20 to 30, then if this was 21 to 30, then my 30s would be in with my 20s. See the problem? I want the 20s to have a column, the 30s to have a column, the 40s to have a column. This ensures that I don't have anything landing right on the line that I don't know where it should go. All right, now your favorite part. It's grade 3 math all over again. Let's make a tally chart. 16 goes here. 18 goes here. 65 goes here. 65 again goes here. 22 goes here. 25, 52, 29. Oops, come on you. 29. 29. 70. 71. 38. 88. 21. And remember, when you hit a fifth one, you make a little line like that? Okay, so you're going to keep going. I'm going to pause the video and then fill it in, because this is not the most exciting video in the world, watching people make a tally chart. So we'll start the video again once everybody's done their tally chart. Back to on. All right, so there's what I got for my tally chart. Please notice that a good way to check your tally chart is to just make sure that you counted everything and didn't miscount something or count it twice. This is 1, 2, 3, 4, 5, 6, 7. 7 times 1, 2, 3, 4, 5, 6, and plus 6 more. That's 48 data points. 4 plus 8 plus 2 is 14, 19, 26, 33, 39, 45, 48 data points. We got them all.
Gentlemen,
I mean, we could have goofed up and maybe put something in the wrong place, but I think we're good. I think we got this. So what does this say? This says that 4 people in the data were in the 10s, and 8 people were in the 20s, and 2 people were in the 30s, and 5 people were in the 40s, and 7 people were in the 50s, and so that's 50s, and 60s, and 70s, and etc. And nobody had 100% because Miss Potter marks really tough apparently. So what are we going to do with this data? We're going to make ourselves a histogram. So turn the page. In my case, I'm actually going to go and cut and paste this nice grid that we have here. So I'm going to go shrink it a little bit, and then I'm going, oh, I didn't want to do that. 1 page, and then make it bigger, page width, there we go. So, okay, don't make it too small, make it so that it fits, and then cut, new. Okay, there we go. Copy, and paste. Okay, so we would like to put this data into a graph. Okay, so let's see. What is my actual tally chart again? Let me go back to my tally chart. Where are you, tally chart? We're over here. So let's see. Let me cut and paste that too. So we're going to cut this out and paste it. And okay, so where's this? There we go. Come on. Nope, that's not going to work. Having some difficulties with this. Come on, I just want it to be beside it. Is that too much to ask? Apparently it is. All right. All right, here we go. All right, so you're just going to have to look back at your data. All right, I happen to have already counted. This is how you figure out a scale for a graph. I happen to have counted, and I know that there are 32 boxes across the bottom, and we need to have 10 intervals. We want the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, all the way up to anybody getting 100. So 32 divided by 10, the closest thing is to count by threes. That's approximately 3, right? It's 3.2. So we're going to count by threes. So 1, 2, 3, tick. 1, 2, 3, tick. 1, 2, 3, tick. So this is my 10s, my 20s, my 30s. 1, 2, 3, 1, 2, 3, 1, 2, 3. It's a waltz. 1, 2, 3, 1, 2, 3. That's one for the music fans out there. One for the music students. 1, 2, 3. Or anybody taking dancing lessons. 60s, 70s, 80s, 90s, and anybody who got 100%, which in this case, wah wah, it's nobody. Okay, now, how high should we make this? Go back to your chart. What's the most that any particular group got? 8. There was 8 people. This is not a strong class that Miss Potter has here. There was 8 people in the teens, right? Or sorry, in the 20s. 8 people in the 20s. So 8's the highest thing. Once again, I've saved you the trouble. I've counted up and down here and found that there's 28 squares going up and down. And I need 8. So 28 divided by 8 is again closest to being 3. 24 with a few left over, right? So again, we're going to count by threes. So 1, 2, 3, that's a 1. 1, 2, 3, that's a 2. 1, 2, 3, that's a 3. 1, 2, 3, that's a 4. 1, 2, 3, that's a 5. 1, 2, 3, that's a 6. 1, 2, 3, that's a 7. 1, 2, 3, that's an 8. And that's all we need. No class had more than 8. So once again, I'll slow down a bit so that people can catch up and they have this chart. Question? Not really, but you just want you want to be able to maximize. I mean, you want to use this great big piece of graph paper and have your little, one little area of the thing used. So you want to kind of make a scale that works for your page. So the question was, does it really matter how much we count in these grid spaces? Well, not really, but I'm just trying to make as efficient a use of space as I can. So that's the smart way to do it. Figure out what the maximum you need across the bottom is, and then count how much space you have, divide. And there we go. Okay, let's put in our bars for our bar graph. How many people were in the tens? 4. So I need a bar that goes up to 4. I'm going to make a fatter pen so that this is easier to see here. Come on, there we go. And there's my bar for 4. Now I'm going to make the next bar for the 20s. And again, this wasn't a strong class. The 20s was the most populated part of the classes here. There were 8 students in the 20s. And so we make a bar that's 8 units high. Then there was 2 students in the 30s. So we make a bar that's 2 students high. Then there was 5 students in the 40s. So 5 students in the 40s, 5 students in the 40s. And then there was 7 students in the 50s. And there were 7 students in the 60s too. And there was 6 students in the 70s. And there were 6 students in the 80s. And in the 90s we had, is it 3? Yeah, we had 3 students in the 90s. And then again, nobody was perfect in this class. So nobody in the hundreds. But then again, there was nobody below 10 either, so that's nice. Okay, question. Oh, I can't hear you. Can you say that, Laura? Yes, I was actually about to do that. I was going to say I might add some color to my graph. How about we shade? Oh, I like that. We'll shade that pink. You know what? Do you get extra marks for doing this? I've got some news for you. We're getting close to the end of class. It looks like the rest of this lesson will wait till tomorrow. And I have some news for you. This is the last time we're doing this by hand. I'm sorry. Were you having fun? Oh, geez, you kind of ruined the lesson. The whole lesson was, boy, isn't this tedious? Wouldn't it be great if we had technology that could do this for us? And then we're going to use the technology to do it for us. We like menial tasks, Mr. K. We were enjoying making tally charts and then bar graphs. Okay, so there it is. This thing, ladies and gentlemen, you might want to put a little bit of, this is a histogram. And what makes it a histogram instead of just your usual bar graph is that it's not counting by one thing at a time. It's got things grouped into sets, right? This is the set of all data that was in the 10s. This is the set of all data that was in the 20s and 30s and 40s and 50s and 60s, etc. And that's what makes it a histogram. By the way, there is one other thing you could do with the histogram. You could, I'm going to use a different color. I'll use red. You could join the midpoints of each of the bars with straight lines, and you can make a broken line graph. Do you remember what broken line graphs are like? Yeah. So broken line graph means it goes up in a straight line, then it goes down in a straight line, then it goes up in a straight line, and then it goes up and over and down and over and down. And the name for this thing with the straight lines, this broken line graph, again, a histogram's like a bar graph, but more fancy. This is a broken line graph, but more fancy, but we call it a frequency polygon. Ooh, who remembers the word polygon from when we were doing geometry? That means many sides. So this case it has, you consider this like it's one object with a whole bunch of crooked sides. So there we go. So that's where we'll end off today with this one that we drew by hand, and then I promise you, we never have to draw them by hand again. So tomorrow, we're going to learn how to do this with our technology. Okay? So I'll stop the video there. Thanks for watching.